Hello and welcome to The Explainer. Today, we're going on a tour of the microscopic battlefield that's raging inside you right now. We're going to pull back the curtain on your immune system, this silent, invisible army that's constantly on patrol, fighting to keep you healthy.
I mean, think about it. It's truly a remarkable process, right? This internal defense force uses these incredibly complex strategies. It communicates across huge cellular networks, and it even learns from its enemies to get stronger. So let's dive in and unpack how it all really works.
All right, here's our game plan. First, we'll get the big picture of this invisible army. Then, we'll look at its secret messaging service, how it actually learns from every single fight, the wild weapons it uses, and finally, the super delicate balance that keeps this whole powerful system in check.
So, to really get a handle on this, you've got to stop thinking about the immune system as just, a random collection of cells floating around. It's so much more sophisticated than that.
This idea of a finely tuned orchestra is honestly the perfect way to look at it. You've got communication, you've got memory, you've got attack, and they all have to work together in perfect harmony. When one section starts to play, the others have to respond instantly. So who are the messengers conducting this whole symphony?
Well, if the immune system is like this bustling city, how do all the different neighborhoods send urgent messages to each other? They use something called cytokines, basically the secret high-speed messaging service of our body's defense network.
These are these tiny little proteins, and they're not just made by immune cells. All sorts of cells can pump them out. They're only produced on demand, kind of like an urgent memo that gets blasted out when a threat is detected, sounding an alarm and giving very specific instructions on what to do next.
And what makes these little messengers so incredibly efficient? Well, for one, a single cytokine can have many different effects on different cells. That's called pleiotropy. They've also got redundancy, which is this brilliant built-in backup system where different messengers can do the same job so nothing gets missed. They are unbelievably potent, so just a tiny amount has a huge impact. And they're only made when they're needed. It's just a masterpiece of biological efficiency.
So the system can talk to itself, but how does it learn? Okay, this is where it gets really, really cool. Think of it like a detective building a case file on a criminal. The first time, it's a slow, careful investigation. But the next time that same crook shows up, the response is immediate.
The very first time you encounter a new threat, the primary response is, well, it's kind of like a turtle. It's slow, a bit sluggish, and it produces a pretty low level of these basic antibodies called IgM. But the second time that invader dares to show its face, the secondary response is a cheetah. It is fast, it's powerful, and it churns out huge amounts of a much more specialized antibody, IgG, which binds way tighter and sticks around for a lot longer.
And the scale of this improvement is just staggering. We're talking about an antibody level that can be 10 times greater or even more than it was during that first sluggish encounter. This isn't just a slightly better response, it's an absolutely overwhelming show of force, all based on memory.
But it's not just faster, it's smarter too. There's this incredible process called somatic hypermutation that actually refines the antibodies between fights. It literally tweaks them to create a higher affinity match that can latch onto the invader with incredible precision. It's like upgrading from a basic skeleton key to a high-security, laser-cut one that fits the lock perfectly.
And right there, that is the entire principle behind how vaccinations work. It's genius, really. Vaccines give your body a safe, harmless preview of the threat. This lets your immune system go through that slow primary response without any actual danger. It builds the memory, it refines the antibodies so that you're totally ready with a powerful, rapid defense if you ever face the real thing.
Okay, so we've covered communication and memory. But what about the actual attack? Let's get into one of the immune system's most impressive tools, the complement system. You can think of it as both an alarm and a weapon, all rolled into one.
So this is a system of proteins just floating around in your blood, totally dormant, until they get triggered. And there are multiple ways to kick it off. Sometimes it's our own antibodies that sound the alarm. Other times, the surface of a microbe itself sets it off. But here's the key. It doesn't matter how it starts. All roads lead to one critical event, activating a central component called C3.
And once C3 is activated,
It unleashes a cascade that culminates in the formation of its ultimate weapon, the Membrane Attack Complex, or MAC. And yeah, that sounds pretty serious, because it absolutely is. I mean, that's just the perfect way to put it. The MAC is this incredible self-assembling structure that literally acts like a molecular drill. It finds an enemy cell, like a bacterium, and it just punches a hole right through its outer membrane. It is a direct, physical assault.
So once that hole is drilled, the invader's fate is sealed. Water and salts from the outside just rush in uncontrollably. The cell starts to swell up, and then it just bursts. It lyses. Gone. It is an unbelievably effective way to take out the trash.
But wait, there's more. The MAC isn't its only trick. The complement system is a total multi-tool. It performs what's called opsonization, which is basically tagging invaders with these little eat-me signals for our scavenger cells. Other fragments of it act as a chemical alarm, triggering inflammation. And it even creates a chemical trail, a process called chemotaxis, that literally guides reinforcements to the site of the battle.
So we have this incredibly powerful system of messengers, memory, and molecular weapons, which of course brings us to our final and maybe most critical topic, control. How on earth does the body wield all this power without turning on itself?
It's the logical question, right? An uncontrolled complement system would be an absolute disaster. It would just tear our own body apart. Thankfully, the body has some very clever, built-in safety switches.
Our own healthy cells have these proteins on their surface that basically act like off switches. They're constantly telling the complement system, hey, stand down, I'm friendly, move along. On top of that, there are other inhibitor proteins that are always patrolling the blood, acting like safety inspectors, ready to shut down any accidental firings. It's this fantastic, multi-layered system of checks and balances. And you can really see just how important this balance is when things go wrong. If someone is born missing some key complement components, they become incredibly vulnerable to certain types of bacterial infections. But on the other hand, if the regulatory systems fail, the system can go haywire. Immune debris isn't cleared properly, and that can lead to chronic inflammation and autoimmune diseases like lupus. It just perfectly highlights that delicate tightrope walk the body has to perform.
So, from secret messengers to adaptive memory cells to molecular drills, we've seen just how dynamic and interconnected this whole system really is. And it leaves you with a pretty exciting question. As our understanding of this beautiful, intricate interplay gets deeper, what new opportunities might we unlock? Maybe new ways to treat disease, or even ways to fine-tune the immune response itself. It's a frontier of medicine that is absolutely still being explored.